students, I am Anirban Banerjee. I am a junior researcher at Talisha. In my previous video, I presented you my research paper on the topic Improvement in CubeSat Communication using a patch antenna. You can find that research paper on the Talisha website. And today in this video, we will discuss and learn about the different components of the CubeSat. So let's start. So first, let's talk about the body of the CubeSat or the metallic framework that is used inside the CubeSat. The metallic framework and its size depends on the type of CubeSat we choose based on its size, that is the 1U, 2U, 6U, and it goes on like that. Then comes the 12U and it goes on like that. So in a 1U we can see it is 10 cm into 10 cm into 10 cm. For a 2U we can see it's 10 cm into 10 cm into 20 cm, and for a 6U we can see it's 10 cm into 10 cm into 30 cm. So for the metallic framework, what kind of material do we choose? Mostly for the metallic framework we use aluminum. We can also use different kind of metals, but we have to keep one important thing in mind, that it should be light weighted, and because if it is light weighted then the whole system will be light weighted, and if it is heavy weighted then the whole system will get heavy weighted, which will be very problematic at the time of deployment and other systems. Now talking about the big satellites and the big space objects that we send to the space, you must have noticed and realized that we use a large amount of gold plating on it. Now a question must have come to your mind, that why do we do it? Why do we use such large amount and cover the whole satellite or the whole body with gold platings? The simple answer to this question is that to save the body from space radiations or the harsh and harmful environment of the space. The gold coating resists the things like that. So now let's talk about the EPS of the CubeSat, that is the electric power supply of the CubeSat. Behind me you can see the whole system, that how it is done. To provide energy or to provide power to the CubeSat, we basically use the solar panel. In CubeSat images you can see that the CubeSat is covered with solar panels at different sides. You can see the whole system and even take a screenshot of this whole system. Here the MPPT is the maximum power point tracking. It is done or it is used to gain the maximum amount of power from the solar panel. So now let's talk about the attitude determination and control system of the CubeSat, that is the ADCS of the CubeSat. To control and determine the orientation or the position of the CubeSat in space, we use different kind of sensors and different kind of system. One of the major system we use is the 3 reaction wheels, and other than that we use different kind of sensors also, which I will tell you in the following parts. So what is a 3 reaction wheel? In my previous video I have showed and I have told to you that what is a 3 reaction wheel, and I have also given a suggestion and a newer version of it to replace it, so that the CubeSat will be lightweight, and you can check those things in the previous video. So now let's talk about the 3 reaction wheel. So the 3 reaction wheel is something like this. There is a wheel and a motor attached to it. So there in a 3D body there are 3 axes, that is the X axis, Y axis and Z axis. X, Y and Z. So the function of the 3 reaction wheels, actually there are 3 motors and 3 wheels here. So the function of these 3 reaction wheels is to move and control the position of the CubeSat in the X axis, Y axis and Z axis. So now how does this work? This works on the basic principle of conservation of angular momentum. When one of these wheels rotate, they generate a high amount of angular momentum, and to conserve that angular momentum, the whole CubeSat body rotates in the opposite side to the direction of the rotation of this wheel. So if the wheel is rotating in this direction, then the CubeSat body will rotate in the opposite direction, that is in this direction. So it's the opposite. So this is how we can control the CubeSat position or the orientation within these three axes by using this three reaction wheel. Now let's talk about the sensors that we use in the CubeSat. First comes the sun sensor. There are different kind of sun sensors and different types of it also. So what is the main purpose, or what does and how does a sun sensor work? So the function of the sun sensor is to calculate or find out the angle which the CubeSat body makes with the sun. Then let's come to the other section sensor that we use, that is the magnetic sensor. The purpose of the magnetic sensor is to find the direction of the magnetic field, and to do this we majorly use magnetometers. So now let's talk about the CubeSat thrusters. So a question has come to your mind that why do we use thrusters in a CubeSat? That what is the function of a thruster in a satellite? So we basically use the thrusters in the bigger versions of the CubeSat, that is the 12U, and the versions more bigger than that. So why do we use a thruster? As you know that a satellite moves in a particular orbit. So sometimes the CubeSat or the satellite gets deorbited due to the solar storms. So to bring back that satellite into the particular orbit, we use the thrusters, and so that it doesn't get lost in the vast space, and also to sometimes control the speed or the velocity of the CubeSat or the satellites, we use the thrusters. You can see or an image may have appeared here, by which you can understand the function or how the whole system of a thruster works. So now let's talk about how the communication of a CubeSat works. So here is a CubeSat in the space, and this is a ground station. This is also an antenna, and this is also an antenna. The CubeSat emits or communicates by using radio waves or radio frequencies, different kind of radio frequencies. So the radio frequencies come back on Earth and they are downlinked to convert them into their true form, that is to get the proper images that the CubeSat sends, or the proper and the correct data logs. Now the data is sent in two different types, that is the analog data and the digital data. Then they are sent to the multiplexers, which filter out the data and give us the important and the appropriate data in their proper form. So now let's talk about the different type of antennas. So now let's talk about the different type of antennas. Here you can see there are two type of antennas, that is the deployable antenna and the undeployable antenna. Examples of deployable antenna are turnstile antenna and the helical antenna, and an example of undeployable antenna is patch antenna. So what is the difference between these two types of antennas? So deployable antennas are the antenna which is at the time of launch is closed, but at the time of deployment, when the CubeSat is ready to is going into space or it is being deployed, that time this antenna opens or come to this final position, or that means that they are finally deployed. The antennas are finally deployed after the deployment of the whole CubeSat body. But undeployed antennas are already present and already fixed in their final position in the CubeSat body. So when the CubeSat is deployed, during the same time the undeployed antenna is fixed into the CubeSat body. So there is no risk or no need to do something to the antenna after the CubeSat body is deployed. So why and what kind of uses do we do with this deployable antenna and undeployable antenna, and which is more good and which will be more betterment for the CubeSat? So the deployable antenna has a huge risk of improper deployment or mission failure. If this part or the deployment of the antenna is improper, then the whole mission will just get into waste, or the whole mission will not work as planned, and so you have to shut down the whole mission. So for this reason we can use the undeployable antenna, that is the patch antenna, because they are already fixed in their position and there is no risk of improper or failure in deployment. But now why don't we use these undeployable antennas mostly over this deployable antennas? That is the strength of the antenna and the functionalities. The deployable antenna has more strength in terms of radio frequencies and different kind of functions of programs that the deployable antenna is doing better than this undeployable antenna. So there are many functionalities constraints in this undeployable antenna. In my research paper you can see that I have chosen the topic that improvement in CubeSat communication using this undeployable antenna. You can see and learn from that through the previous video. So this is the pros and cons, that this is better in functionalities than this, but this will be more good and more proper in terms of mission successfulness, and because the risk of improper deployment or the risk of mission failure due to the improper deployment of the particular antenna is getting removed. So now let's come to the next topic, or let's see an overview of how the CubeSat communicates with the ground station. So now let's see the overview of the whole system. So here is the CubeSat which sends packets in form of audio tones to the FM radio. Then this goes to the modem. Then it goes to the AX.25 for encoding and decoding purposes. Then it goes to the terminal operator for data handling. At this point it is reached to the ground station. So this is how CubeSat sends data through radio waves from the space, and this is how it gets to the ground station. So now let's talk about the final part of the whole mission, that is the deployment of the CubeSat. So this is the deployment mechanism used in a CubeSat. Now let's see this whole system. There is a box, there is a spring, here is the CubeSat, and there is a gate. This is the basic things that you have noticed in this. So first we take the box or the deployment box, and here is a spring. At the first point, this door is closed, while the CubeSat body is inside it. So when this is closed, there is a pressure applied, or the string here is compressed. So there is some potential energy conserved in the string. So when this door is opened, that time the potential energy will be released, so the CubeSat will go out of the box, or it will launch itself out of the box. At that position of closing, so the potential energy is there in the string, so the CubeSat body is fully fitted into the box, and when the gate is opened, the potential energy will be released, the string will come back to its normal position, and the CubeSat body will move from here to here or get itself launched out of the box. This is how we give the CubeSat, or we put the CubeSat into that particular orbit that it needs to be. So this was it for today's video. Let's meet in the next video and discuss more about CubeSats. For then, thank you. So, as you have seen this video, that means you are interested in CubeSats, satellites and rockets and space science. So follow our channel, and from the next month we will also give free webinars. So subscribe.